Hello everyone, today we are going to discuss the problem word ladder, and in here the requirement is that if we are given a start value or a begin word, we have to reach to the end word using the word list that is given to us, and we have to tell that from here to here if we have to reach what all values we can cover, and we have to find the shortest transformation it will take for this value to reach this value. This is the requirement. Okay, so let's draw uh, some relations. So we can see that from HIT you can move to HOT. From here you can move to DOT. Every time if you see carefully, there is just one character difference that we are making. The I is getting replaced with O. This is HOT. Here the H will get replaced with D, so we will get DOT. And here the T will get replaced with G, we will get DOG, and in the end we can see that it will give us COG. So you can see that it is asking you the shortest transformation it will take for you to reach from begin word to the end word, right? So whenever just give me a minute. Whenever you are asked that from a particular value you have to reach a particular state, and we have to do it in minimum time span, and you can see that there are couple of combinations that we are making to reach this point. It's always a BFS. It's always best to use a BFS in such scenarios if we are able to figure out that yes, it is a graph solution, and yes, we have to reach a particular state and we have to reach it in a minimum state. That's where we use BFS. You might ask that why BFS and why not any other algorithm. The reason being is, if you see in BFS we always use a queue, and in queue we make sure that we keep on pushing all the values at once, so and so and so on, and in the end, the moment we discover the value for the first time is the time when the value was discovered in the minimum transformation, and at that point we return the value. So that's why we say that using a BFS in such scenarios is a better idea. Fine. So now to solve this question, there are actually two approaches, although both of them involve BFS and Q and all. But there are two different ways you can save the values within your hash map or hash set overall. But let me explain you both the approaches really quickly. So see, one approach could be that you can have a hash set, okay, and in that set you can have all these values HOT, DOG, and all these values, okay. And initially you have your begin word as hit, okay. So you entered hit inside your queue, and then you are saying, okay, from hit what all, just compare all the values, like for hit, okay, for each character move from A to Z, replace H with A, with B, with C, with D, and so on, and see if I replace H with AIT, BIT, CIT, DIT, is this matching with any of the value that is present inside my set? If it is, then I'll consider that value and I'll add it to my queue, and I'll mark that value is visited so that I do not visit that again. Okay, that is one thing. Second, once I have done replacing all the values of this first character with any of the other values from A to Z which is actually present in my set, my next point will be to move ahead and replace all the values of the second character or second index value with, again, from A to Z we will replace all the values. And then there comes T. Here we will do the same thing. We will try to replace all the values of the character, and then see if it is present in my set. If it is, then I'll add it inside my queue and I'll mark it as visited, and so on. In such scenario, what will be the time complexity that we can expect? We can expect that we will have, at max our queue can have, in the worst case, can have all the values, correct? So n for the all the values inside my queue, and for each value I'll be traversing through each character, and for each character it is said to us that the number of words will always be the same in one string. So I'll say number of words, or character length, I can say character length of my string, okay. So I will be traversing to H, I, and T and for each each character I'll be traversing from A to Z, that is equal to 26. So this will be a time complexity overall. So that is one thing. The other approach which I really like and which I guess the interviewer will like as well, and I have implemented that as well. What is it? That you will replace that particular character with a start. So what does this mean? Let me show you. So you got an HOT, right? What you will say, replace H with a star. The value you will get is OT. Now this star OT will have all the values which this particular character can have. So in here what you did, HOT, you replace H with star and you get star OT, and in the star OT you saved HOT. Fine. Then you did the same thing with O as well. So H star T and you saved HOT again. Okay. And then you did HO and star and you replace HOT. And this is basically a map which is having an array list. So this is a part of array list, right? The next character that you will get is DOT. You will again do the same thing. Replace D with star, so you will get star OT. You already have a star OT, so you just have to push this character DOT now, this string DOT now. The next character that you will, next string that you will have out of DOT will be D star T. You will see that there is no character or no string is D star T. So I'll make a new one and D star T and I'll assign DOT to it. Okay. And then I'll do the same thing. I'll replace T now. So it will be DO star. I can see there is no value as DO star. So I'll make a new string with an array list and assign DOT to it. Okay. Then in the next go I got DOG. So I'll do the same thing, star OG. There is nothing as star OG, so I'll make star OG and I'll assign cock to it. Okay. And sorry, I'll assign dog to it. Yeah. Then I'll replace star O with star and so on. So you will see that this DO star will have DOT, DOG. Okay. This star OG will have DOG, LOG. Okay. So you can see that we can create such combinations, and in each combination we can say that what all values can appear here. Okay. Now let me tell you how this will help. So this part of the code was related to the same thing. We are doing the same thing. We are taking each word, and for each word we are replacing that ith character with start, and I'm checking if it is already present in my map, then just directly add it. If it is not, then create a new array list and then add it. So this part of code is the same thing that we have done over here. Once we are done, okay, once we are done, what we know is that we will always have a begin word, right? So let me take a queue. Okay. Inside my queue, let me insert the begin word that was hit. Okay. So I have inserted hit here. Fine. Let me clear this up. It's not very clear. Okay. I'll have hit here. Okay. So once I get a hit here, what I'm doing, if you see it carefully, what I'm doing, I'm replacing each character with star, and this time it will be star IT. I'll check if is there any other combination which have star IT. It will say no. I'll say okay, it's fine. Then I'll say, is there any other combination with H star T? This time I'm replacing this with star. So I'm asking, do you have any other combination with H star T? It will say yes, actually I have it, and that is this hot. Okay. So I'll say okay, pick this hot inside my queue. This will be my next step. And so on, and the moment we reach to the end goal, we will return count. Okay. We are using a set as well. This is basically a visited set. We will check whether this particular value is visited or not. And I am doing count as well. If you see, let me remove everything. Yeah. In the code, I'm doing count plus as well, and this is the count that I'm returning at the end of the day. Okay. And what this count signifies is that at each level, let's suppose I was at point A, and from point A I could reach to B, C, D. Okay. And when I'm at point B, I can reach to three other values from C and three other values from D. So I can say, what I can say, if from A I can reach to B, C, D, and from this I can reduce to E, F, and x, y, and z, l, m. Okay, so I can say this is level 1. These all three values are at level 2. These all are at level 3, and at any point this is the value that I'm expecting, so I'll return level 3. So that's what I'm doing. I'm calculating the size, that okay, at current stage what is the size I have, and go on to remove until and unless this size becomes 0. Until and unless I have popped out all the 3 elements that I wanted, I will be in level 1. And in the next level, I'm saying that until and unless I have popped all these 7 items that I have, I will be at level 3 no matter what. Once I've done with all these 7 levels, then I'll move to the next levels. And that's where we are doing the count plus plus. So that is the code. I guess it helped. I will ping this code as well in the comments, but overall I have used the second method that I discussed, that we will be using a star method. You could have used a to z method as well, where you take a string and for each character you replace it from a to z. This will be a better time complexity, because you will not be traversing from a to z every single time. You will have your time complexity will actually get reduced very. So earlier what happened, your time complexity was n into length into 26, right? Now your time complexity will be n will remain same. Okay, the you will be traversing through all the length, right? But you will be just traversing through that particular length, and you will be checking whether this particular character exists or not in my this particular character exists in my map or not. And searching a map is just a constant time space. So in that case, we reduce this extra time complexity that we were using. So this is a better solution, but if you give the other solution as well in the interview, that should work as well. So that's all. I hope this helped. Thank you so much.